Hey guys, Mrs. Kane here. So I am going to walk you through the practice problems with wave-particle duality and using Debroglie's equation. So our practice problem is determine the wavelength in meters of an electron with a mass of 9.11 times 10 to the negative 31 kilograms, having a velocity of 5.65 times 10 to the 7th meters per second. So we are going to be using the de Broglie equation. So we have our wavelength is equal to Planck's constant, so 6.6 times 10 to the negative 34, divided by the mass of our particle times the velocity of our particle. So we're going to go ahead and just plug in all of our numbers that we got from our problem. Okay, and to make our math a little bit easier, I'm going to round this to 9 instead of 9.11 and this to 6 instead of 5.65. Okay, so just like we normally do, when we're multiplying, we're going to split them down where the times symbol is. And we're going to break them into two parts. So 9 times 6, the 9 from here and the 6 from here, gives us 54. Then we're going to take our exponents. So remember, if we're multiplying exponents, we are really adding them. So negative 31 plus 7 gives us negative 24. So now we're going to recombine. So if we leave it like this, 54 times 10 to the, that should be negative. There we go. Negative 24. Okay, it's not in proper scientific notation because we have two numbers before our decimal. So we're going to move it. So I know it's hard to see with my poor board. There's only one decimal point right there. So 5.4 times 10 to the negative 23. Since we moved the decimal place over 1, we also have to change your number. Okay, so our number went down. So now we're going to take... Oh, Lord. That should be 23. We're going to take our Planck's constant and we are going to put our new number in for the bottom. So this is the number we got from taking our mass times our velocity. Okay, now we're going to divide. So remember, we're going to divide, write down the x's. Okay, I rounded my numbers to make them a little bit easier to work with. So 7 divided by 5 gives me 1.4. Sorry about that glare. Okay, when we do 10 to the negative 34 divided by 10 to the negative 23, we're really subtracting. So negative 34 minus negative 23 is going to give me a negative 11. So 1.4 times 10 to the negative 11 is how many meters, okay, my wavelength would be. And that would be it. We would be done. So I'm going to walk you through the second example in just a second. All right, guys, our second question is to determine the wavelength in meters of a .22 caliber bullet with a mass of 3.98 times 10 to the negative 3rd kilograms, having a velocity of 395 meters per second. So again, we're coming back to de Broglie's equation. So our wavelength is equal to Planck's constant divided by our mass of our particle times our velocity of our particle. So we're just going to go ahead and plug in the information that they gave us. Okay, so Planck's constant at the top, our mass times our velocity, and we are going to round these numbers just to make it easier and nicer for us to work with. So I changed 395 to 400 and then put it into scientific notation. So it will be 4 times 10 to the second. So then we are multiplying, and again, we're going to divide right down where the x's are. So we're going to do 4 times 4 gives us 16. Take our exponents, negative 3, adding because we're multiplying, plus 2 gives us negative 1. When we put it into scientific notation, it would be 16 times 10 to the negative 1. Okay, but we can't leave it like that because there's two numbers in front of our decimal. So we're going to move the decimal place over 1 to get 1.6, and then we do times 10 to the 0, okay, because we moved our decimal place. So we go from negative 1 to 0. All right, so now we're going to take that number and plug it in at the bottom, okay, because we just did our mass times our velocity. So we're going to take Planck's constant And we are going to divide it by this 1.6 times 10 to the 0. So 1.6 times 10 to the 0 is really just 1.6. So we're going to do 6.6 divided by 1.6, and that's going to give us about 4. Okay. Then we're going to look at our exponents, and what we're really doing is negative 34 minus 0, which is still just negative 34. So this right here would be our wavelength for that problem. All right, guys. That's the last of our de Broglie equation examples. If you still need help, come see me for office hours, shoot me an email, set up a conference. I'm here to help. All right, bye, guys.